First topic of this video is to find the rth term from the end of the binomial expansion. That is, we need to find a particular term from the end, not from the start. Okay, so how do you do that? First, you know for a fact that a plus b whole power of n is nc0, a power of n minus 0, b power of 0. See, 1 into a power of n minus 1. See, 2 into a power of n minus 2, b square, and see 3 into a power of n minus 3, b cube, plus and so on, plus ncn minus 1 into a power of 1, a power of 1 into b power of n minus 1, plus ncn into a power of b power. Okay, now from the start, don't you think this is the first term, this is the second term, third term, fourth term from the start? Right. Now what are these terms? This is the nth term, this is the n plus 1th term. Right, because in binomial expansion we have n plus 1 terms in total. Now, using that logic, if we write the terms from the end, don't you think these are nothing but terms from the end of an expansion? Just writing binomial expansion as B is what? N plus 1, Tn plus 1, Tn, n minus 1, n minus 2 and so on up till 1. Right. What is this sequence? Is it familiar? Yes. This is in AP, arithmetic progression. Right. And how do we find the nth term in an arithmetic progression? Tn is equal to a plus n minus 1 into d. Right. So, here what is a? First term, n plus 1. And what is d? d is the common difference. So, common difference is second term minus first term. That is t2 minus t1. Here we get n minus of n plus 1. So, what is this? We get n minus 1. So, common difference is minus 1. Yes. And a is n plus 1. Right. So, with these two, can we not find the nth term? Yes. Here, we are trying to find the rth term. So, not to confuse the terminology, we use the rth term from the end. So, let's try, in place of n we put r, and we get what? N plus 1 plus r minus 1 into d is minus 1. So, what do we get? Minus r plus 1. So, we get how much? We get n minus r plus 2 plus dr. So, this term is the rth term from the end, but n minus r plus 2th term from the beginning. Right? Because if you substitute n and r in this formula, you will get the term from the end as well as this term from the beginning. Right? Because it will start from 1 to n and into 1. Okay? So, this is the rth term. Now, you will get the term itself here, as in if it's 4th term from the end or 5th term from the end, you will get which place it's there from the beginning. Right. But how do you know what is the value of the term? We use a general term formula. That is, we know for a fact that TR plus 1 is equal to NCR a power of n minus r b power of r. Right. And here we know that r is equal to, that is TR directly, is equal to n minus r plus 2. Right, this is the rth term from the end. So, this is equal to this? Yes. So, r plus 1 is equal to n minus r plus 2. So, we need to find the value of r in order to substitute r in this equation. So, we get what? N minus r minus plus 1. We'll take minus 1 here. Right? So, in short, T n minus r plus 1 plus 1 is equal to NC n minus r plus 1 a to the power of r minus 1. If you cancel, you get that. And b to the power of n minus r plus 1. So, this is how you find the rth term from the end. This is the general term. You can use general term to find the rth term from the end or n minus r plus 2 term from the beginning. Okay. Now let's see a problem in order to apply this concept. And please bear in mind, this is extremely easy. You need not remember the formula or memorize the formula. You can rather remember the process how we have come to this formula and then apply it. Okay, so this is the problem and we'll use the concept that was just taught to solve this problem. Okay, here he is asking us to find the fourth term from the end in this expansion. And what is the value of n here? N is 10. And what is r here? It is 4. We know for a fact that the term from the end, that is tr end, is equal to tn minus r plus 2th term from the beginning. Right. So let's substitute n and r here. So what do you get here? N minus r plus 2. So what is n minus r plus 2th term from the beginning? N is 10, 4 plus 2. So how much we get? 6 plus 2, 8th term from the beginning. That is 4th term from the end is equal to 8th term from the beginning. So there's nothing but, how do you find this term? tr plus 1, and here r plus 1 is equal to 8, so r is 7. 10c7 to 2x whole power of 3 into minus 1 x square whole power of 7. So how much do we get? 10c7 is nothing but 10c3 using the properties of binomial coefficients. And then we get how much? 8x cube into, here minus to the power of odd, we get minus here, by x to the power of 14. Okay, so how much do we get? Minus 120 into 8 by x to the power of 11. So we get how much? Minus 960 into x power of minus 11. So this is the fourth term from the end in the expansion, and or we can say the eighth term from the beginning. Okay, so this is how you find this problem. Okay, the next topic of today's video is how to find the greatest term in a binomial expansion. So this topic is a bit difficult to understand, but once you understand the process that I am teaching you on how to find the greatest term, then it's extremely easy for you to apply the same concept while solving problem. You need to find the greatest term of x plus a whole power of n. Okay, this is the binomial. So you need to find the greatest term in the expansion x plus a whole power of n. So what you need to do is first find out tr plus 1 and tr in this expression. So that means, what is the general formula of tr plus 1? NCR, a to the power of n minus r and b to the power of r. So substitute this x and a in place of NCR. So we get what? NCR, x to the power of n minus r and a to the power of r. This is tr plus 1. What is tr? tr is nothing but NCR minus 1, because we are finding r, so we need a term before it. So a to the power of n minus r plus 1 and b to the power of r minus 1. So that is NCR x to the power of n minus r plus 1 into a to the power of r minus 1. Right. So what we need to do is, after finding tr and tr plus 1, you need to divide tr plus 1 and tr. That is tr plus 1 divided by tr. What do we get? We get NCR, this is the one, right? X to the power of n minus r, a to the power of r, by NCR, this is minus 1, x to the power of n minus r plus 1 into a to the power of r minus 1. So now you need to simplify. This will cancel, and this r, this one, a will go on the top, x will remain in the bottom. So we get NCR by NCR minus 1 into a by x. Right. Now how do you simplify NCR by NCR minus 1? You know the formula of NCR, n factorial by n minus r whole factorial into r factorial by n factorial by n minus r plus 1 whole factorial into r minus 1 factorial. Okay, and this will be into a by x. So how do we get this? Cancel this. R factorial can be written as r into r minus 1 factorial. There's nothing but, if you say 4 factorial, you can write this as 4 into 3 factorial, right? These both are same. So that is the formula. So we'll cancel this as well. And in here also it's like n plus 1 factorial into n factorial. So this is the notation logic we are following to cancel this. So this will also get cancelled. Okay. So now what do we get? We get n minus r plus 1 by r into a by x as the result when we divide tr plus 1 by tr. Okay, so this is the final result when we divide tr plus 1 and tr. Right. So now if you observe this, tr plus 1 and tr, if you divide, this division can be greater is equal to and less than 1. Right. Because if you divide, you might exactly divide it and you might be getting a value greater than 1. You might be getting a value less than 1 as well. Right. So that means there are 3 inequalities that are applicable to tr plus 1 by tr. Isn't it? It can be either greater, less than or equal to 1. We know for a fact that tr plus 1 by tr is equal to n minus r plus 1 by r into a by x. Plus 1 by tr can be greater and less than or equal to 1. So how do you do this? We say n plus 1 by r into a by x greater than or equal to less than 1. Right. Now take r on one side and remaining on the other side. What do we get? We get n minus r plus 1, isn't it? Okay. So we get n plus 1 by r minus 1 to x by a, because I am taking this x by a this side, and then you will be getting n plus 1 by r 1 plus x by a, and then take r that side and get this side. So you get final result as n plus 1 by 1 plus x by a is greater than or equal to or less than r. So this is the final result that you get after dividing tr plus 1 by tr. You might get any of the values. Right. So what happens now is this r here is the greatest term that we get. But in order to find out this value n plus 1 by 1 plus x by a, you need to understand a few things. So this value n plus 1 by 1 plus x by a, if you divide, there are 2 possibilities. If you see, if you divide any number for a fact, there are 2 possibilities. What is that? That is n plus 1 by 1 plus x by a can be an integer. That means these 2 are perfectly divisible by each other, and you will be getting one integer out of it. And n plus 1 by 1 plus x by a can not be an integer. Not an integer. So there are 2 values that you might get when you divide n plus 1 by 1 plus x by a. That is, you might get an integer and you might not get an integer. So now let's consider these 2 cases and this result to identify whether what happens when we divide these 2 and when we get an integer. Do we get a greatest term? If yes, how many greatest terms do we get? Now that is what we'll see. So now let's consider case 1. For case 1, where we will say that we will get the result as an integer m. So how many cases do we have? Here we know for a fact that tr plus 1 by tr can be greater than 1, can be equal to 1 or can be less than 1. So we need to consider all these 3 cases and see what happens with the division. So when tr plus 1 is greater than tr, just take tr that side, and you need to also understand what happens when tr plus 1 is equal to tr and tr plus 1 is less than tr. So when tr plus 1 is greater than tr, what happens is the range of the values that r could take first will be what? From 1, 2, 3 and so on up to m minus 1. And when tr is equal to tr, the range of values that r could take is only m, because r is equal to m. We get a perfectly divided integer. And then when tr plus 1 is less than tr, what is the value that we get? The values will start from m plus 1, m plus 2 and so on up to m. If you see these 3 ranges, right, when the rth term, that is r plus 1th term, is greater than rth term, then the range stops at m minus 1, assuming that we can have a perfect m in the entire range. So tr plus 1 plus greater than tr will be within this range. Tr plus 1 is equal to tr, the value of r will be m because there is a one perfect integer m, and tr plus 1 less than tr will have the remaining values. So m plus 1, m plus 2 and so on up to n. So the entire range is from 1 to n. Okay. So now what we need to do is substitute r in this range. So what do we get? T2 greater than T1, T3 greater than T2, T4 greater than T3 and so on. We get Tm greater than Tm minus 1. Okay, that is the first result that we got. What is the second result? It's simple. If you substitute m here, we get Tm plus 1 is equal to Tm. So this is the second result. Now what is the third result that we get? Substitute m plus 1 here. We get Tm plus 2 less than Tm plus 1, comma Tm plus 3 less than Tm plus 2 and so on. We get how much? Tn plus 1 is less than Tn. Right? So this is 3. So now try to equate these three values. What do we get here? We get T1 less than T2 less than 3 less than 3 4 so on. Tm minus 1 less than Tm. Right? And we know from 2 that Tm is equal to what? Tm plus 1, and we know from 3 that Tm plus 1 is greater than Tm plus 2, greater than Tm plus 3, greater than Tm plus 4 and so on, greater than Tn plus 1, greater than Tn. Right. So now what is the final value that you get? The final value that you get is this, and if you observe, there are two terms in here that are greatest. So that means the greatest terms, when we divide n plus 1 by 1 plus x by a, and when this result in an integer, then the greatest terms are Tm plus 1 comma Tm. Okay, so this is how you find out the greatest term when it is perfectly divisible. Now let's see what happens if it's not an integer, when this result is not an integer, that is case 2. This is case 2. If it's not an integer, it's very easy. We will not have this case, right? Because there is no perfectly divisible value at all, isn't it? So in that case, there are only two cases that exist, that is tr plus 1 greater than tr, and then we get tr plus 1 is less than tr. And the range of values r could take is from 1, 2, 3 and so on up to m, because there is no integer in here, and then from here it will take us m plus 1, m plus 2 and so on up to n. Right. And now what do we get? Substitute the values. We get T2 greater than T1, T3 greater than 3, T4 greater than 3, and so on up to Tm plus 1 is greater than Tm. Okay, and what do we get here? We get Tm plus 2 is less than Tm plus 1, Tm plus 3 is less than Tm plus 2 and so on, and we get Tn plus 1 is less than Tn. Okay, so now consider this as equation 1 and equation 2. Now, what happens in this case? If you equate these two equations, what do we get? We get T1 less than T2 less than T3 and so on up to Tm plus 1, right? And then here also Tm plus 1 is greater than Tm plus 2, greater than Tm plus 3 and so on, greater than Tn. So if you see here in this equation, we have only one term in the middle, and that term is the greatest term. Okay, so whenever we have a case where m is not an integer, we will get Tm plus 1 as the greatest term. Whenever we have m an integer, we get two terms, that is Tm plus 1 and Tm as the greatest term. Okay, and here, because it's not an integer, you will be having a question. We'll get some fraction value, right? So what do we take? Because we need the term. The term can't be a fraction, it can be a natural number, isn't it? Or an integer, right? So what do we get in that case? In that case, we need to consider the integral part of m. That is step of m. Just consider the integral part and you will get the answer. Okay, so this is how you find the greatest term in a binomial expansion. You need not apply all this, but you need to apply until this point in a problem and you need to decide whether you will be getting an m or not. If you get m, then take Tm plus 1 and Tm as the greatest terms. You will get them as equal, and if it's not m, then we will get only one greatest term, that is Tm plus 1. Okay, now let's see a quick problem. So now let's see a quick problem using the concepts that were taught before. So we need to find the numerically greatest term in the expansion to 2 plus 3x whole power of 9, where x is equal to 3 by 2. So now what we do is, immediately first we'll see the binomial expansion. It's given as 2 plus 3x whole power of 9. What you need to do is, you need to get this in the form of x by a, as in 1 plus 3x by 2 whole power of 9 into 2 power of 9. You need to get this term out here because there is no variable associated, and if you get 2 outside, then you will be able to simplify the binomial expansion very easily. So that is the reason we'll just get it out and get this in this form. Okay, and then now the second step would be to find tr plus 1 and tr. So what is tr plus 1 here? You know the formula, it is NCR into a power of n minus r, b power of r. So what do we get here? N is 9, CR is something which we need to find out. And what is a here? 1. That is the reason it's easy to simplify. If we take 2 power of 9 outside, take this also outside, 1. And then what is b here? 1 power of 9 minus r. What is b here? 3x by 2 whole power of r. Okay, and then tr is what? NCR minus 1, a to the power of n minus r plus 1, b to the power of r minus 1. So we get what? 2 power of 9 into 9cr minus 1 into 1 power of 9 minus r plus 1 into 3x by 2 whole power of r minus 1. So cancel 1, anyways it's 1. So this r will go and this will go into the top. So we get 9cr by 9cr minus 1 into, this will go into the top, so we'll get 3x by 2. Okay, we'll take this as mod because whenever we have x as negative, we can use that. Okay, so now 9cr by 9cr minus 1, we substituted this NCR by NCR minus 1, we got n minus r plus 1 by 2, 1 by r in the theorem that we were just solving. So we get what? N minus r plus 1 by r into 3x by 2. You know for a fact that n is 9. So we'll get 9 minus r plus 1 by r into 3x by 2. So we get how much? 10 minus r by r into 3x by 2. Here, substitute the value of x. We get how much here? 10 minus r by r into 9 by 4. So we get, in short, we get 90 minus 9r by 4r. Right? So this is the final result that we get. Second step is to find tr plus 1 and tr, and then we'll divide it. We got one result. Third step is take tr plus 1 by tr as greater than or equal to 1. We get 90 minus 9r by 4r is greater than or equal to 1. So we get how much here? 90 minus 9r is greater than or equal to 4r, and we get 90 is greater than or equal to 13r. So we get r is less than or equal to 90 by 13, which is this, is less than or equal to 6, 12 by 13. Okay, so here r is less than or equal to 6, 12 by 13. If you see here, what is the integral part here? 6. And here if it means that we are finding R. So R is nothing but we are trying to find which term is the greatest term in this binomial expansion. And here if you see, we are getting 6 as the integral part and there is a mixed fraction here. We can't have a fraction in order to find the term in the expansion, right? The term can be a integer, positive integer. So here we only consider the integral part, and this is the case where n plus 1 by 1 plus x by a is not an integer. And whenever that is the case, then what do we take? We get only one greatest term, that is Tm plus 1. Okay, so now we got R as 6. We need to find this. So we get T6 plus 1 is equal to, substitute general term and then we'll get the answer. So we get what? 2 power of 9 into 9c6 into this one. What is a here? 1. So 1 power of 9 minus 6 is 3 into 3x by 2 whole power of 6. Right. So we get how much here? 2 power of 9 into 9c6 is 9c3 into x, substitute x is what? 3 by 2. So we get 9 by 4 whole power of 6. So we get in short 2 power of 9 into 3 power of 9 power of 6 is 3 power of 12 into 2 power of minus 12 into 9c3. So by substituting we get, simplifying, we get 7 into 3 power of 13 by 2. Okay, so this is the greatest term in the binomial expansion, 2 plus 3x whole power of 9. The same method that I've taught you in order to get the greatest term. The only thing is, once you identify whether m is an integer or not, you will directly see what is the greatest term and do. Okay, so I hope you understood today's video, and if you have any questions, please feel free to comment below so that I will be helping you answering those questions. So if you like my video, I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. So till then, I hope you all have a safe day and a wonderful week ahead. Bye.